Well, hi there, boys and girls. Welcome to Fireside Chats with Mr. Jones. Today we're going to be talking about exponents. First, let me stoke this fire. Exponents, we're going to be talking about a few things. There's going to be a lot of information in here. So pause if you need to. But this is going to be a week's worth of information for you. I'm going to have a few questions on here after this video on the post, and then a few things on Prodigy as well for you. Exponents. Exponents are the numbers that are like the little numbers above a big number. So with an exponent, we have a few things. We have our base, which is our base number, and then we have the exponent. Well, that exponent can be any number, that base can be any number, but my main goal is to show you the relationships between what any base is and what that exponent does to that base. So, for example, if say I had 2 to the second power, you would think, oh, 2 plus 2, well, that's 4. But so is 2 times 2 is 4, and 2 squared is 4. Now that's where it can kind of get confusing. This is the only example that really gets confusing. So we have to realize that 2 squared is 2 times 2, which is 4. Right? Now, what if we change that exponent? Instead of 2 squared, it's 2 to the third power, or 2 cubed. 2 cubed would tell us not to do 2 plus 2 plus 2, because that would be 6. Rather, it's 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. So 2 cubed is 8. All right. Now we can see this in a couple other ways. If I say I have a square area that is 2 feet by 2 feet, well, then I have 4 feet squared. So that's where that comes from. That square footage of like a house or an office or a garage or anything. All right. Now, if we want to buy a car and we're looking at the cubic feet of cargo space, well, you're not just talking about the square footage anymore. You're actually talking about a 3-dimensional object. So say we have this 2 foot by 2 foot area, or this box. All right, and we draw that to become a 3-dimensional object that is also 2 feet deep. All right, we would end up with how many cubic feet? Well, we'd have 1 square here, 2 squares here, 3 squares here, 4 squares here, and then we'd also have 1, 2, 3, 4 on the back side as well. Or actually the fourth one is here hidden, but we would have 8 cubic feet, or 8 feet to the third power. That means there's 3 dimensions. It means it's a 3D object. All right. If we get to 2 to the fourth power, or to the power of 4 here, again, 2 times 2 times 2 times 2. So really all we're doing is we're just multiplying everything, and that would be 16. Don't really need to use that right now for what we're doing in math, but realizing that these exponents, well, what's happening to each thing is we're multiplying the next thing by 2. So 2 to the 5th power, we don't have to do 2 times 2 times 2 times 2 times 2. We can just do our previous 2 to the 4th power times 2, and we end up with 32. So then 2 to the 6th power is going to be 32 times 2, which is 64, and so on and so forth, okay? Now, the thing that's crazy cool about that is this isn't always multiplying by 2. Say we have a base of 3. Well, 3 squared would give me 3 times 3, which would be 9, right? Well, instead of saying, okay, well, what is 3 to the 3rd power? We wouldn't be multiplying 9 by 2 like we were doing before when our base was a 2. Actually, we're going to be multiplying 9 by 3. So 3 to the 3rd power, 3 cubed, is going to be 3 times 3, which is 9, and 9 times 3, which is 27. So that means 3 to the 4th power, 3 to the power of 4, will be 27 times 3, 81. All right. So anytime we have a base that's any number, that's pretty much what we were multiplying the previous term by. So 5 squared is 25. Well, 5 to the 3rd would be 25 times 5, 125. And 125 times 5 would be 5 to the 4th, because 5 times 5 times 5 times 5. We multiplied 5 4 times. Not 5 times 4 to get 20, but 5 or 4 separate times. All right? Now that's the gist of what we need to do with exponents. However, we can go backwards with these exponents as well. So let me give us 4 to the 2nd power. Be 4 times 4. All right, 4 times 4, 16. All right. Now 4 to the 3rd power. 4 times 4 times 4, 16 times 4. What would that be? Well, I could do 4 times 6, which is 24. 4 times 1, which is 40. So 24 plus 1, 24 plus 40, 64. All right. Now, notice how I had to take 16, and if I multiply it by 4, I get 64. Well, if I take 64 and I want to go to 16, I'm going to divide by 4. All right. So that means if I want to find out what the first power, 4 to the 1st power is, that's just 4. Because 16 divided by 4 would be 4. Okay, so then if we go further with this pattern, well, it would be 4 to the power of 0. A lot of you might be thinking, oh, that's got to be 0, because 4 and 0, 4 times 0 is 0. Actually, look at our pattern. 64 divided by 4 is 16. 16 divided by 4 is 4. 4 divided by 4, it's not 0, rather it is 1. All right, now let's go one step further. Can we have negative exponents? Absolutely. 4 to the power of negative 1. Now, why would we do that? Well, let's first off see what happens here. Okay, see how our pattern, we're dividing by 4 all the way up. So we're going to do 1 divided by 4. Don't make it too complicated. It's just going to be 1/4. Or, if you like decimals, 0.25. 25 hundredths. All right? If we keep going, we'll just get smaller and smaller. Now, what would be the purpose of this negative exponent piece? Well, think about time. All right? If we have time going on, we can talk about situations going back in time. So yesterday would be to the negative 1st power. The day before that would be to the negative 2nd power, which is hitting home to us right now and why I'm teaching you through this is for the coronavirus. All right, it seems to be every 5 or so days, this virus has killed 2 times more people than it did the previous 5 days. So we can go back, all the way back, 5 days at a time and see this pattern where it's not just going up in a normal trajectory, rather it's bending and starting out slow, but then it goes faster and faster and faster, and eventually it is out of control. All right. Remember when we were working on slope-intercept form in multiple different ways for both integrated and for 8th grade math, our equation can look just like this. Y can equal x squared. All right, we can look at the exponential activity or the exponential pattern just by doing a simple table here. All right, so just like before, let's fill out this table. All right, so this would be a situation where we're squaring everything that happens. So each day, something, or let's just say it's a day, more cases are happening. All right, so let's say in day 1 or day 0, y equals 0 to the 2nd power. Well, 0 squared, 0 times 0, that's going to be 0. All right, so I'm just going to have a point here at 0, 0. 0 days have passed, 0 people have been infected. All right, let's then go on and let's replace x with 1. Y equals 1 squared. Well, 1 times 1, 1 day, 1 person's infected. You might say, well, how did that person get infected? I have no idea. But it occurred. All right, so we have 1 down here. Not a big deal, just 1 person. All right, let's replace this x now with 2. So now we have 2 days. That 1 person didn't realize they were infected. They then go out and mingle around with a bunch of people. 2 people didn't get infected. Rather, 2 times 2, 2 squared, which is 4. 4 people are now infected. 3 additional people were infected between days 1 and 2. So now we're up to 4. All right. Now y to our 3rd day, 3 squared will give us 3 times 3. That'd be 9. So 3rd day, 9 people. Now we're really starting to see this trend kind of kick up a little bit. All right. Y equals 4 squared. That'd be 16. Day 4, 16. Y equals 5 squared, 25. Day 5, now 25 people are infected. Day 6, 6 squared, that'll be 36. And 7, y equals 7 squared, 49. So go 7, go up to 49. And we'll see that this trajectory is not linear. It's actually a non-linear curve. And eventually, it's going to start getting out of control. All right. More people that show up, exponential amount of handshakes can. All right. You'll notice too our pattern here. We start off with 1. All right. We add 1. Next pattern, 1 to 4, we would add 3. To get from 4 to 9, we would add 5. To get from 9 to 16, you would add 7. 16 to 25, add 9. And you'll see that we're not adding the same amount to get to each step. It's actually increasing by 2 more people each time. All right. All right, now here's another way of exponents affecting our lives. All right. We have, instead of x to the power of 2, we have 3 to the power of x. In this situation, we can have our exponent changing and our base staying the same. So say our exponent, we'll just keep this pretty simple. Just do 0 through 5. Let's see what happens with our graph then too visually. We can have y equals 3 to the power of 0. Replacing our 0 for our x, so we have y equals 3 to the power of 0. Now remember what we did before. Is 3 to the power of 0 0? No, it's actually 1. Anything to the power of 0 is going to be 1. So at day 0, first day, one person was infected. I have a point right there. All right. One day then passes. We then have y equals 3 to the power of 1. 3 to the power of 1 was 3. All right, you just have 3 once. Then we have y equals 3 to the second power. That would be the second day. Well, how many people are infected now? Well, 3 squared is 3 times 3, 9. All right, let's start plotting these points. 1 and 3, 2 and 9. Y equals 3 to the third power. We have the third day occurring now. 9 times 3 is 27. So 3 days, 27, right there. Now you can really see what's going on here. Our line is actually going up quite drastically. Now, this would be a terrible situation, not the situation we're in right now, but this is showing that each day or each time frame, whatever this would be, everything is increasing by 3 times. All right, so y equals 3 to the fourth power, 3 times 3 times 3 times 3. Now that's going to be 27 times 3, which is going to be 81. Now 4 and 81, that's all about off my page. You'll notice that our line is non-linear. This is actually a non-linear line. It curves up. It goes on steeper and steeper and steeper. Yes, it might start out slow. However, as time goes on, it gets steeper and steeper. You might say, well, I don't need to know any of this at all because, it is what it is. Infections are going to occur and whatnot. I can't do anything about it. Well, yeah, you can. It's that important to stay away from everybody. Say one person is infected and they come in contact with 5 different people. Well, that one person might infect 3 more. Now there is 4. Now each 4 of those people, they infect 3 people themselves. All right. Now instead of 4 people, we now have 12 people infected, and that can continue this exponential growth. Now, something that you may have to deal with, hopefully someday in your lives later on than now, is a birth of a child. All right. Think about how that occurs. You have 2 cells. They come together. All right. What happens to those 2 cells? 2 cells, they break up into 4 cells. Those 4 cells then break up into 8 cells. Each of them split twice. Then 16, then 32, then 64, then 128. And eventually, after a time, you then have a fetus, you have a baby, all right, with thousands and thousands and thousands of cells. This also goes on to the question about, would you rather have a penny a day, not an extra penny, but like your amount doubles each time, starting with a penny, or would you rather have $1 million right now? Well, you sort that one out yourselves here in a second. All right, here we go. We got $1 million. We have 1 cent. You have 1 penny. All right. 2 days pass by. You will be given 2 pennies. All right, because it doubled. All right. You now have 3 pennies. You don't just have 2 pennies. Okay. Next step, double that. We now have 4 pennies plus 2 pennies plus 1 penny. Man, we will have 8 cents getting to us. We now have 16 cents, 32 cents, and 64 cents. A week has gone by. We have gotten 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 cent. We are just over $1. Should have taken that $1 million, huh? Well, let's see. That's only 1 week. We still have a few weeks to go. All right. Well, you now, instead of getting 64 cents, you now get $1.28. $81.92. Let's take $81.92. That's after week 2. All right. We've now gone 2 weeks. We now have $81 being given to us that final day of the 2 weeks. And actually, the original question isn't 60 days. It's actually only 28 days. So it's only 4 weeks. Would you rather have the $1 million still? Gone 2 weeks. We've only been given $81 in 1 day. However, we still have all this money from before that we can also add up, but we'll just ignore that for right now. We don't need to deal with that. So let's see, $81. And then the final day of week 3, you would be given $10,464. So at the end of week 3, you would have $10,000 plus all the money you've been given every day after that. Doesn't even come close to $1 million. And really, in the original question, we only have 1 more week left. So what can we do? Do we stop here and just say, you know what, I made a dumb mistake? Or do we keep going? Well, let's see. Oh my gosh, we only have 4 more days left, and we have only $83,000. We should have taken $1 million. 2 more days, and we're only at $300,000. But look, we now have $669,696, and we have 1 more day left. And that will give us $1,339,392 on that final day. Now, that final day alone, obviously, is way more than the $1 million that we could have gotten on day 1. However, remember, we can add all the numbers from all the previous days as well. So that's how exponents and exponential growth can be really helpful for looking at the coronavirus or anything else, or fish in a pond. But that's how you can retire at a proper age. If you start saving money now, or start saving money as quickly as possible, whether that's $5 a week or $10 a month, that money can grow exponentially throughout time, and you become a millionaire. If you ever looked at a stock in the stock market, the trend for that starts out low, goes up higher and higher and higher as time goes on. It goes up exponentially. It bends. It's a bending effect going up. So this is a pretty important concept as far as your lives go. Hopefully you got something from this. This is a huge thing. I pretty much packed a week's worth of material into 1 video. So if you need to come back to this video a few times throughout the week to finish your work, then please do so. Sorry, it got a little darker in here. Sunshine went down. I'm going to go back to my fire. As you can tell, it's burnt out. Have a good